Everybody have a happy Halloween? Oh, well, that stinks. What questions do you have? Any questions at all? Before we get going? Continue on with our discussion on log properties. All right, so remember yesterday or Wednesday, we talked about how logs break up over certain situations. So just right again over to the side here, if you have a logarithm of a product, how can you rewrite that? Oops. Good. Right. Well, remember when we multiply, we add exponents. So that's our log property, right? Because logarithms are exponents again. So we've got a log of a product, it breaks up as the sum of the logs. Likewise, if you've got a log of a quotient, how does that break up? Good. And then finally, we also had the one where if we had x raised to the r power, what can we do with the r? Good. Bring the r down in front. Good. So those are the three log properties that we talked about on Wednesday. And the examples that we did were the logs were broken apart and we put them back together again. So today we're going to start this first example of the logs are together. We want to break it apart. So let's look at this first one where we've got log base b of square root of r over u times v. Before I do anything else, what do you think we might want to do with that square root? Okay, good. Yeah, so write it as a power. So you kind of did two steps at once. That's exactly right. So we want to first write it as a 1/2 power. And this is something that's pretty common going forward in other math classes. That a lot of times if you've got a square root, you might want to write it as a 1/2 power because you might want to play around with the fact that we can express it as an exponent to help us do other properties. So you'll write it as a 1/2 power, and then we can bring it down in front like so. So that's the first thing that we can handle is that square root, make it a power, bring the power down in front. That makes sense so far? Okay. What do we do next? Good. Yeah, we've got r over u times v, so we can change it to a subtraction. So you'd have log base b of r minus log base b of u times v. One thing to be careful of, this 1/2 is in front of this log. We're rewriting this log, so that 1/2 would apply to the whole difference. Well, I've got that in parentheses. Because when we just separate it into a subtraction, it represents that whole log piece, right? So that 1/2 would distribute over each piece. See anything else we can do? The u and v, good. We got u times v. And just like what I mentioned there in that previous step, notice that minus sign applies to the whole log. So again, when you write this as a sum, you want to make sure that that minus sign applies to the sum of the logs then. And that's probably broken down as much as you can get, right? Put that single thing in there. You could, if you don't like all the parentheses, you could distribute the minus through and then distribute the 1/2 through, but this is perfectly fine the way it's written. Are there questions on that example at all? Is there really anything different going on in the next one? Or is it the same kind of problem? Same kind, because we have ln here, and ln is our natural log, which is log base what? E, right? E is the base of that. So it's still asking the same kind of problem. Just we wrote it as a natural log, but the natural log satisfies all those properties of logarithms that any logs do. So what would you do first here? Good, put 3/5 down in front. Good. So now we have 3/5 natural log of m minus natural log of n on that. Pardon me. It's okay?
So we just drop the E entirely. Like we don't write it as
We don't, when the ln implies that the base is, so we don't write the E there at all. Yeah, so that, the natural log notation, if you had natural log of x, that means the same thing as this. So if you wanted to write it with a base of e, you would actually want to change it to log. Other questions on that one at all? We'll take a couple minutes and work on the next two, and then we'll chat about them. What did you do first in part C? Okay. And which power would I use? Good. Everybody got that first step? Is that okay? Okay. What'd you do then? Good. Yeah. Okay. Separate the x squared y. Good. Oops. Forgot my parenthesis, didn't I? All right. So we've got a log of a product. So I can rewrite that as log, sum of the logs, and then finally, what's the last thing you can do here? Yeah, bring that 2 down. Good. And then if you really wanted to, you could distribute the, pardon me, distribute the 1/5 through if you wanted to. You could have also, you could have also done taking this exponent and distributing to each piece on the inside first, because it's a product. And then you could have broke up the product and brought the and then brought the powers down. You'll get the same answer. Either one works. Is this one okay? Okay. All right. What did you do for the next one? What would you do first? Oh, sorry. Let me mention one more thing. Notice that this one doesn't have a base on it. When you see log without a base, what base do you assume? 10. Good. Remember, log is common log. We assume it's base 10. Sorry, I meant to say that before we even started that problem. But just to remind, so remember, ln is the special notation for log base e. Log without a base is our notation for base 10. All right. Sorry. Go ahead. So what'd you do first? Good. Change the division to subtraction. I agree with that. For this one? Okay, so does that 4th power apply to the 16 though?
Yes.
Yeah, so 16x to the 4th, I would do the x to the 4th, but not to the 16, right? So I need to do something first before I break the 4 down in front. What do we need to do first? It's 16 times x to the 4th. Yeah, I got to do addition, right? I got to do log base 2 of 16 plus log base 2 of x to the 4th, since it's multiplication. I got to do that first. They're multiplied together. Can we do anything with this first one, by the way? No. Good. That's one of the reasons why I put that in there, right? There's nothing we can do here. I know, it's really, really tempting to break it up over the sum, but remember, logs don't break up over sums. Yes?
I just have a question about parentheses. So can you put it out in front of the log and make it like a whole parenthesis, or does it have to be like just around like the y squared plus c? Or does it matter?
You mean take this parenthesis and put it
Yeah.
there?
Yeah.
No, it needs, this y squared plus z is inside the whole log.
Okay.
So
So
it
it
needs,
would make it wrong.
yeah, it would make it wrong. Because if you write it the other way, it looks like the y squared is inside the log and the plus z isn't.
Oh yeah.
All right, so again, we've got this product here, so we need to make sure we separate the multiplication. Then what can we do? Now you can put the 4 in front. Is that okay with everybody? There's one more thing we can do to simplify. Can we compute what log base 2 of 16 is? Yeah. So remember what that's asking you. It's what power do you need on 2 to give you 16? So 2 to the what power is 16? 4, right? So this answer will be 4. You can simplify that to a 4. So you'd have log base 2 y squared plus z minus 4. I'm just going to distribute the negative sign through, and then a minus 4 log base 2 of x. Remember again, logarithms are exponents, right? So anytime you've got a logarithm, if you've got numbers in there, it's just asking you, what power do you need on the base to give you the input? So in this case, what power do I need on 2 to give me 16?
Why is the second one subtraction?
I distributed the minus sign through. Yeah. I could, if I left it as parentheses, it would be a plus. I just went ahead and distributed the minus through. You know, if you want me to do, I can put it back in there. It doesn't matter. I could do that for the previous step. Either or works. I just didn't want to write in parentheses, so I distributed it. Is it okay? You want to see one more like that, or are you okay with it? Okay. All right. So this is more of the same ideas of using log properties and making sure we understand what logs mean. So this part A is just more with variables rather than numbers. A second ago, I asked you, what power do you need on 2 to give me 16? That's what you're thinking of with a log question, right? This one's asking you, what power do you need on B to give you B to the R power? What would the answer be? R, yeah. Remember that this really is just a statement about inverse functions, right? Remember, generally speaking, if you apply a function to a number and then apply its inverse, you get back to where you started, right? Right? We talked about inverse functions a couple of sections ago, right? If I do a function and then undo a function, that's what inverses do, right? They undo the function and get back to where I started. Logarithms and exponentials are inverses of each other. This says do the exponential and then do the logarithm, right? Plug a number in the exponential and then plug that output into the log. Well, it should undo what the exponential did. I should get back where I started, which was with the exponent. So this really is just an inverse statement. Likewise, if you wrote it this way, if it's written that way, it's the same kind of statement. It's just reversed. This says, first do the log and then do the exponential. Well, logs and exponentials cancel each other out, so what answer should you get? This says, look at this property here, right? This says take an input, put it in the function, take that output and put it in the inverse function. Where should I get back out to? Well, the R again, yeah. Where I started, right? I'm starting by plugging R into the log, taking that output and plugging it into the exponential. That's the same idea as this property, right? This is the whole point of doing logarithms. They undo the exponentials and vice versa. Exponentials undo logs. Right? So this also should equal R. So this property is going to help us in the next two cases. Okay. So let's look at part B. We have e to the 2 times natural log of 5 plus natural log of x. Let's start by putting together the exponent as a single logarithm. Let's do that first. What would you do first to combine the logarithms in the exponent? What would you do first? Good. Natural log of 5 times x, right? I've got a sum of the logs, so we can combine them as multiplication. So you'd have 2 natural log of 5x, like that. What can you do with the 2? Yeah, bring it up as a power, right? Now notice, this one's just, I want to contrast, before we finish this off, I want to contrast this between what we talked about up here, right? That 4 that was on that x to the 4th did not apply to the 16th, right? However, when we bring the exponent up, the exponent goes on the input. So this square here now does apply to that whole 5x. It applies to the whole input. Okay? It's a little bit different than what we had before. All right, so now look at this property. What's ln again? It's log base what? E. So notice I've got this situation, don't I? You've got e to the log base e. So again, those undo each other. So what are we going to end up with? Yeah, the 5x, the whole thing squared, right? Which we could rewrite as 25x squared if we distribute the square. So again, when you've got same base, you've got the base of your log matches the base of your exponential, and you're composing them, they undo each other. You just get to where you started, get the input. So see if you can do the same kind of thing for part C there. First. Okay, so you have to be a little bit careful. So that 3 is in front of that log. Does that 3 apply to that part too? No. So what should we take care of first before we do the division? Yeah, we gotta put the 3 up first, right? Good. So we need to take that 3 up as the exponent first. So notice that's a little bit different than the previous example, right? Notice the previous example had the 2 in front of the parentheses, so we took care of the sum first because it's inside the parentheses, right? But that 3 that's out in front of log x only applies to the log x. So I got to take care of it first before I do the division. When you take care of the division, what do you get up in the exponent then? What will you get next? Good. X cubed over 2. And now again, log, when it's written with no base, means log base what again? 10. Good. So are these inverses of each other? Yes. So what do we end up with when we're done? X cubed over 2. Good. And when I wrote these two problems, I purposefully put parentheses around that one and not that Make sure that we know which order we need to do it in. This idea okay? This idea of doing, pardon me, inverse functions in both directions is going to pop up in our next section when we start talking about solving equations that involve exponential functions and involve logarithmic functions. So being able to undo them, right? So for example, when you've done equations with square roots in them, you squared both sides to get rid of the square roots, right? Those kind of ideas. So same idea here. If you've got an equation that involves an exponential function, you might want to take a logarithm. If you've got an equation that involves a logarithm, you might want to do an exponential. So we'll talk about that in the next section when we get to it. Any questions about either of those two before we go on? All right. So this one looks a little strange, but it's just another example of a problem that's just trying to get you to practice with the properties. So every single part of this, you should be able to write in terms of log base b of 2, log base b of 3, or excuse me, of 5, and log base b of 7. Okay. And now it's just telling you letters to represent each of those with. That, by the way, that does not say a equals 2. It says log base b of 2 equals a. Okay. When we're done, we should just have a, b's, and c's and no logs. That's the idea here. Okay. All right, so the first thing I notice is that we have log base b of 10. This is a first example. How can I rewrite 10 as a product? 5 times 2, good. Something on my screen. Just trying to get it off. 5 times 2, and now I've got a log of a product, right? I've got log base b of 5 times 2. With our properties, how can we rewrite that? So I want to use my log properties first before I try to introduce the a and the b, the capital A and the capital B. I've got a log of a product. Good. I've got a log of a product, so I can write that as the sum of the logs. And now do I have something that represents log base b of 5? B. And do I have something that represents log base b of 2? A. Notice again, we should have no logs in our answers here. Okay. It's not log base b of 2, or sorry, it's not a equals 2. It's a equals log base b of 2, that whole expression. And likewise with the 5. All right, let's see if we can do something similar with part B. What would you do first, do you think? Good, turn the root into an exponent. So make that log base b of 7 to the 1/2. And with logs, we like turning things into exponents if we can, because what can we do with the exponent? Yeah, move it to the front, right? So we get 1/2 log base b of 7. And according to what we have in the beginning of the problem, what's log base b of 7? C. So I can just write that as 1/2 c. All right, so same idea. See if you can work on C and D. Again, the idea is to try to break up your insides into 2s, 5s, and 7s. Use your log properties, then to break it up and do log base b of 2, or of 5, or of 7, and then replace the letters. So work on those two for a second, or maybe a couple of seconds, and then we'll chat about them. Okay, make a subtraction. Good. So the log base b of 5 is good, because what can I replace log base b of 5 with? The capital D, right? So that one's good. Can I replace this with something yet? No. So let's go ahead and work on this until we can get it to replace with something. What did you do to rewrite the 14? 7 times 2, that works. Because then how can you rewrite that part? Good. Right. Rewrite it as a product, and then I can split the product up as a sum. So I've got log base b of 7 plus log base b of 2. And now do I have something to plug in for each of those three things? Yeah, log base b of 5 we said was capital B. Log base b of 7 is C, and A. Good for the other one. Okay. That makes sense what we did? Maybe. Okay. What'd you do for D then? Okay. So I can make the cube root as an exponent. Is that what you said? Okay. So make it to the 1/3 power, like that. And then turn it into subtraction. I like that. Okay. All right. So we're at a half instead of a third. Sorry. All right. So cube root becomes a 1/3 power. Notice that cube root is only on the 28, so it stays on the 28 there. Right. We've got then we've got division, just like we had in the previous problem. So we just do that as a subtraction. And then I've got the 1/3 power on the 28. We can bring it down in front. We okay so far with those? That part okay up to that point? Okay. You said something about rewriting the 28 and the 35? Yep. Well, how can you rewrite the 28? Okay. 2 times 2 times 7. Works for me. And then the 35? 5 and 7. Good. Why do I keep writing that as a half? All right. How can you rewrite log base b of 2 times 2 times 7?
Log base b of 2 plus log base b of 2 plus log base b of 7.
That works for me. Good. Yeah, so I've got a product of three things. Well, logs break up products into sums. So that 2 times 2 times 7, I can break it as log base b of 2 plus log base b of 2 and a 7 as well. And then finally, for the 5 times 7. Good. That's a base B, sorry. Yeah, are we okay with how those split up? And now everything can get replaced at this point, right? Log base B of 2 is A, and there's 2 of them. So I can write that as 2A, because it's going to be A plus A. Right? Log base B of 7 is C. Log base B of 5 is B. And then I could simplify this a little bit if I distribute and combine, but that works just fine with what we have. You can distribute the 1/3 through, distribute the minus sign through, and combine your like terms if you want. Yes?
Would it count it wrong if you put A plus A instead of 2A?
Should be fine. Yeah. I will be fine with it if you throw that on the test. So, yeah. I assume Levis, I don't take it. Is it okay? Any questions on that at all? Yeah. All right, so let's look at the last part here. As I mentioned before, you'll notice on your calculators you only have 2 buttons for logs. You've got the natural log button and the LOG button. However, we also have been talking about being able to do log base B, or in this case I've written A. But you can do log base whatever you want, as long as the base is positive and not equal to 1, right? So how do you calculate logarithms when I've got something like part A here where I have a log base 7 of 3? Well, it's a really, really hard question to ask. Something on the screen, but I can't get it up there. It's a really, really hard question to ask of what power do I need on 7 to give me 3? I don't recognize 7 to some power equal to 3 easily, right? Okay. So there must be some other way that we can get a decimal approximation, and that's what we refer to as the change of base formula. It turns out that I can change a log base whatever to any other base that I want by doing a quotient. So this is going to be log base, say C, for whatever C that I want, of B, divided by log base C of A. This is what's known as the change of base formula. I can change any log of whatever base that I have in terms of any other log for whatever base I want, as long as the bases are allowed. Now, of course, I probably don't want to do this for like 12 or 87 or 1/17. I probably want to use this formula either with a common log or a natural log, because that's what's on my calculator. The whole point of doing this is to be able to get decimal approximations. Okay? So if I want to do this, I'm going to use common log or natural log. So you could do this as log of B over log of A, or ln of B over ln of A. Either one. They both give you the same answer. Okay. So if we look at this first example, where we have log base 7 of 3, we can rewrite that as either log of 3 over log of 7, common log of 3 over common log of 7, or ln of 3 over ln of 7. Either one will give you the same answer. Doesn't matter which one you use. The only thing you need to make sure of is when you're typing it in your calculator should automatically put a parenthesis when you hit the button. Make sure you close the parenthesis before you put your division sign in. Okay. Just make sure you hit the closed parenthesis before you start typing in divided by the other one. It does not matter which one you use, you will get the same decimal. Okay. What did you get for the decimal here? Say it again. 0.565. Is that what everybody got? Okay. Using either one, right? If you do both, you'll get the same number. Literally, the decimal places will match all the way across your screen. That okay? You can do the same thing for the other ones. Doesn't matter what it is. So again, I don't even have to, I could move the 1/3 down in front if I want to, right? I could make this a 1/3 power and then move it down in front. Or you could type the whole thing in your calculator, you'll get the same number. Okay? So in this one, you could move the 1/3 down in front first. Right? Make it a 1/3 power and then move the power down. And then use your change of base formula. You could do it that way. So when you type this into your calculator, you would have something like that. If you wanted to, you could do it that way. Or you could just use your change of base formula immediately. And I'm going to flip it to common log because, again, it doesn't matter which one you do. If you typed this into your calculator, you'd have something that looks like this. The reason why I'm doing it this way is to just show the different parentheses you would need. If you don't know where your cube root button is on your calculator or how to type it in, you would want to convert it to a. Oh, I've lost the parenthesis. I must have erased one. I had one in there to start with. You want to change your root to a 1/3 power anyway. Using your exponent button. Some of your calculators will just automatically put it up in the exponent if it's got kind of that math print on. Okay. If you don't, it might be just all in line. But make sure that if it's in line, you put your parentheses around your exponent as well. So again, you could move the 1/3 out in front with the cube root to start and then do your change of base formula, or you can just leave it alone and just use your change of base formula. Either one works. What value did you get out of this, by the way? So what others got? Good. So how would I rewrite the last one here? Good. Yep. Doesn't matter what the base is. It could be pi. It could be whatever you wanted. And again, you can use log or use ln, either one. And what do you get when you do that one? 192? Okay. So whatever the others got? Any questions on change of base formula at all? Okay. All right. Well, that finishes up section 4.4. On Monday, we will do section 4.5, which is solving exponential and logarithmic equations. We'll also do 4.6 next week. So we have 4.5 and 4.6 next week. 4.6 is doing some word problems involving exponential and log functions. Your next test is a week from Monday, the 11th. All right. Have a good one. We will see you on Monday. Have a good weekend, everybody.